Today we're going to talk about geometric sequences. How do I write the nth rule for a geometric sequence? Just like we did with arithmetic sequences, we wrote a general nth term rule. We're going to do the same thing, but this time with geometric sequences. First, you need to know the definition of a geometric sequence. It is a sequence in which the ratio, notice ratio, between any two consecutive numbers is constant. A constant ratio, which we represent using a lowercase r, is the constant ratio between terms in a geometric sequence. The first thing you need to be able to do is identifying geometric sequences. Take a look at number 1 here. I have a sequence 4, 8, 16, 32, and 64. In order to figure out if there is a constant ratio here, I'm going to look at consecutive terms. Consecutive terms are ones that come right after one another. I'm going to create a ratio between those consecutive terms. So a ratio between 8 and 4 gives me 2. A ratio between 16 and 8 also gives me 2. And a ratio between 32 and 16 gives me 2. So yes, this is a geometric sequence, and the constant ratio here is equal to 2. Number 2, I have a sequence, and it's very clear to me that to get from one term to the next, I'm adding 4. This is not a geometric sequence because there's actually a common difference here. We know that this is called an arithmetic sequence. Take a look at number 3, 512, 128, 64, 8. There could be some sort of pattern here, but because I don't see a common difference like an arithmetic sequence, and I don't see a common ratio like I did in the geometric in number 1, this is not a geometric sequence. Number 4, if I look at my terms here, if I take the consecutive terms 1/4 and 3/4 and set up a ratio between them, I can't divide fractions. So multiplying by the reciprocal gives you the same solution as dividing. 1/4 divided by 3/4, I would rewrite as 1/4 times 4 over 3. The 4's cancel and I get a constant ratio of 1/3. If you were to do this with 1/4 and 1/12, you would end up getting the same answer and with consecutive terms throughout the sequence. This is known as a geometric sequence. Now we're going to learn how to write a rule for the nth term in a sequence. Just like with geometric sequences, just like with arithmetic sequences, we have a recursive formula and an explicit formula. Each part of the formula represents something that you would find in the sequence. The recursive formula is a sub n is equal to a sub n minus 1 times r. A sub 1 would be equal to whatever the first term is. A sub n is still equal to the nth term, just like in arithmetic sequences. A sub 1 is equal to the first term. A sub n minus 1 is the term before the nth term. So for example, if we were finding the 10th term, a sub n minus 1 would be representing the 9th term. R is equal to the constant ratio. The explicit formula, just like with arithmetic sequences, this is the one that we're going to be using most often. A sub n is equal to a sub 1 times r to the n minus 1. A sub n is still equal to the nth term. A sub 1 is equal to the first term, and r is equal to the constant ratio of the sequence. Now let's take a look at using the explicit formula. The directions say to find r, find the explicit formula, and find the 7th term. My sequence is in red here, 6, 24, 96, and 384. If I set up ratios between consecutive terms, I can see that my constant ratio for this sequence is 4. So r is going to be equal to 4. Now that I have that information, I also know that a sub 1 is equal to 6 because it's the first term in the sequence. So, using my explicit formula, I'm going to plug in what I know in order to get the nth term rule. A sub n is equal to a sub 1, which is 6, times 4 to the n minus 1. 4 is my constant ratio. This results in my nth term rule. But the problem asks me to take it a step further and find the 7th term. So I'm now going to take my nth term rule and I'm going to plug in a 7 in place of n. The 7th term is equal to 6 times 4 to the 7th minus 1. This gives me 4 to the 6th power, which is equal to 4,096. So the 7th term in this sequence would be 24,576. In letter B, I also have a sequence here, 3, 1.5, 0.75, and 0.375. Again, if I set up ratios between consecutive terms, I find that my constant ratio is 0.5. I'm going to set up my explicit formula. A sub n is equal to the first term, which is 3, times the constant ratio, which is 0.5 to the n minus 1. This gives me my nth term rule. Now I want to find the 7th term. A sub 7 is equal to 3 times 0.5 to the 7 minus 1 power. I'm plugging in 7 in place of n because I'm looking for the 7th term. A sub 7 is equal to 3 times 0.5 to the 6th power. And when I evaluate this, I end up getting an answer of A sub 7 is equal to 0.046875. On a problem like this, you would be allowed to use a calculator. Now I'm going to write the explicit formula and the corresponding exponential function. Geometric sequences, when you graph them, they produce the curve like exponential functions that we've already talked about this year. Using this information in red, I'm going to come up with the formula and then I'm also going to write it as an exponential function. So here's the information that I'm given. The 5th term is 1,792 and the constant ratio is equal to 4. So in green here, I've just jotted down some of the pieces of information I need. A sub n, which is the nth term in this case, is equal to 1,792. R is equal to 4, and n is equal to 5. I got that because this was the 5th term. If I plug in what I know, 1,792 is the nth term in this case, is equal to A sub 1 times 4 to the 5 minus 1 power. The only thing that I do not know in order to write this formula is A sub 1. So I'm going to use this to solve for A sub 1 so that I can write that general nth term rule. When I solve, 4 to the 4th power gives me 256. I'm solving for A sub 1, so I divide by 256, and I get that A sub 1 is equal to 7. Now I can plug that into my explicit formula, and I get A sub n is equal to 7 times 4 to the n minus 1. As an exponential function, you can kind of think of n as your input into a function and A sub n as your output to a function. So all we have to do to write it as an exponential function is replace A sub n with f of x and the n with an x. It's very easy. Now take a look at letter B. The 3rd term is 18 and r is equal to 3. So again, I wrote down some information that I might need to solve this problem. A sub n is equal to 18, r is equal to 3, and n is equal to 3 because I'm talking about the 3rd term. A sub n is equal to A sub 1 times r to the n minus 1. That's my explicit formula. I'm going to plug in for what I know and solve for what I do not know. 18 is equal to A sub 1 times 3 to the 3 minus 1 power. 18 is equal to A sub 1 times 3 squared, which gives me 9. Divide by 9 on both sides, and I get that the first term is equal to 2. The reason I have to solve for my first term is because that's what I have to have in order to write my nth term rule. I've got to know that first term, and I've got to know my constant ratio. A sub n is equal to 2 times 3 to the n minus 1. As an exponential function, remember that n is representing your input, and A sub n is representing your output. So, exponential function would be f of x is equal to 7 times 4 to the x minus 1. I replaced A sub n with f of x and n with x.